For 4.7, we're going to talk about the inverse of the trig functions. So, if you remember from college algebra, in order to find the inverse or whether a function had an inverse, we would evaluate like the horizontal line test on the graph of this function. So, if you look here, this is the graph of sine. Now, you see that it intersects the function many times, like so. So, determine whether this passes or not the horizontal line test. Cosine is very similar to this, so you can make your own judgment on that, right? So, what do we do if we are looking for the inverse of a function that doesn't pass the horizontal line test? So, what must be done is that the domain needs to be restricted. So, we're going to cut the graph of the function down to a small piece where it's only unique numbers, where it doesn't repeat forever. Okay, so we went from not being able to have an inverse to having an inverse. So here it is, the definition: the inverse sine function, and we write it as this: sine to the power -1. It's the inverse of the restrictive function sine of x, where x is going to be between -pi/2 and pi/2. So if you have something like this, where you're saying there's a number equals to sine inverse of another number or another input, what it means is that you switch the x with y, and you have this expression here. You have sine of y is equals to x. Alright, where y is going to be between -pi/2 and pi/2. It's just saying that the input is going to be restricted for this definition, right? X and y are switching, so x is now between -1 and 1. So this is the original graph that we were evaluating above, and here's that horizontal line that only touches once everywhere on the graph, and that's what we're looking for. So now that we have that, we rotate it above the line y equals x, or pretty much just switch all the points from x to y and y to x. So what we have here is the point -pi/2, -1. Well, if we switch them, you get the point -1, pi/2. And so you get this new shape that looks very similar to the original graph, but it's still between just a few numbers, and it passes the horizontal line test. Okay, what can we expect? So here are some examples, right? You hopefully know what sine of pi/6 is. Okay, it comes out to be 1/2, right? So those are some things that we've kind of done already many times, so it's not too hard to understand that. Then sine of pi/4 comes out to be √2/2. Then we get sine of pi, which happens to be 0, and then sine of -pi/4, which happens to be -√2/2, right? So what does that have to do with the inverse? Is going back to the top here, if you are evaluating sine of 1/2, right? Well, let's do it. But now you only have to think where between -pi/2 and pi/2 does 1/2 happened. And so it happens at pi over 6. So notice how this was now the input, but it became the solution, but because you're evaluating the inverse of it. Okay, then you're going to look at the second example where you are looking for where do I get square root of 2 over 2 when evaluating sine, and you're going to say, well, it could happen at many points. But it's good if you actually understand what I'm saying here, is that it can happen here at square root of, pi over 4, but it can also happen here, right, at 3 pi over 4. But since this value here is outside of the shaded area, which is pi over 2 to negative pi over 2, then this is not considered. And then we only get one solution, right? Because that's the problem. In order to have an inverse, we cannot have a choice of answers. Not duplicates like that. So square root of pi over 4 is the solution for this, right? Then you say, well, is there sine inverse of 0? And the answer is yes, but it is not going to be pi because it's outside of the domain for the restricted function. So 0 is an answer, but it's not going to be pi because pi is all the way over here and it's outside of the domain for the inverse function. Then we have the last example. So same thing, right? Where do I get negative square root of 2 over 2? And that happens down here, right? So whatever measurement that is, so think about it, it has to be between negative pi over 2 and pi over 2. It cannot be some larger measurement, like if you went around the unit circle all the way around, right? Something like 7 pi over 4 or something like that. You're going to have to write it in simpler terms. So negative pi over 4, right? The value of the answer has to be between negative pi over 2 and pi over 2. Alrighty, so here is the function cosine, and again, there's a horizontal line that's crossing through, and in order to figure out whether it has an inverse or not, it has to pass the horizontal line test, and right now it doesn't. But as you saw with sine, we're going to make adjustments for this and make it work. So here's the definition for the inverse of cosine. The inverse of cosine is denoted as cosine to the negative 1, or the inverse cosine function, and it is the inverse of the restricted function y equals cosine, where x is now between 0 and pi. So we have this definition, right? Y is equal to cosine of x, which means cosine of y is equals of x. Okay? Then you say y is going to be between 0 and pi in this definition here on the bottom, and x is going to be between 1 and negative 1. Okay? And their graphs are right here. So what is important to understand is that this is the function f of x, right? This is some function, and this is true for any functions that you look at. This is just theory in general. Okay, if this is f of x, right, and you go over here, this is the inverse function. Okay, this is in terms of y comma x or x comma y. The inverse function is going to be y comma x. Right, we're switching the values so long as it passes the horizontal line test. Right, so the domain in this function is the range of this function. The range of the original function is the domain of the inverse function. Right? Here we go from 0 to pi. That is the domain in the function. Well, from 0 to pi is the range of the inverse function. Okay? And just how I drew those arrows going in one direction, well, you already noticed that we can go in the opposite direction too. Kind of like figuring out the inverse of a number takes you back to the original input, if you will. So here we have some examples, and the same thing, we're going to just run through some basic examples like what is cosine of pi over 6, and hopefully you can follow along with me and name them right off the top of your head, and if not, just kind of take your time to do it. Square root of 3 over 2 is cosine of pi over 6. Then we have cosine of pi over 2, which comes out to be 0. Then there is 2 pi over 3, and that happens to be negative 1/2. What is cosine at 0 is going to be 1. And then what is cosine at pi? Negative 1. Okay, so we're going to do the same thing here as we did with the previous example of sine, and we're going to find the inverse of it. So where between 0 and pi do I get square root of 3 over 2? Well, only in pi over 6. Where would I be? Well, where would I be? If I plug in 0 and I compute the inverse of it, right? It's kind of saying like what input would give me 0 is what I'm asking. And right now it's simple, right? It's whatever I inputted in the previous function. Then, if we go like that, well, where is negative 1/2? It is located at 2 pi over 3. Cosine of 1 happens at 0, and then cosine of negative 1 happens at pi. Now, let's talk about the inverse tangent function. So we didn't really talk much about the graph of tangent before, but let's talk about the function now. And so this function actually passes the horizontal line well. It doesn't. So the full function or the full graph of it doesn't pass the horizontal line test. So we have to restrict it like we did with the others, but it leaves this nice smooth line in between, right? Like one piece of the graph is nice and smooth, so it doesn't look like a cutout like all the other functions, is what I'm trying to kind of say, I think. So the inverse function tangent to the power negative 1, or just the inverse tangent, is the inverse of the restrictive function y equals tangent. Now, for this case, x is going to be between negative pi over 2 and pi over 2, but please do notice that it doesn't say equal to. It just says greater than and less than. So we're not including the endpoints, so be on the lookout for that, and hopefully that makes sense. So what we're saying is that y equals tangent means x equals tangent inverse of y, where negative pi over 2 is less than y, less than pi over 2, and x is going to be between negative infinity and positive infinity. Just picture this graph kind of rotated on its side, and that's where those values come from. So here is the explanation for the domain, the range, and all of that. And like I told you before, here is on the left the function f of x, and on the right side is the inverse of things, right? And just the way this goes in that direction, these values switch over to y comma x. The domain switches over and becomes the range on the other, and then the range of the general function becomes the domain of the inverse. And just how we go from one place, we can map back from the inverse function to f of x. Okay, so again, this is the original function, which goes from the bottom left to the upper right when we're graphing it that way. But if it's been turned into the inverse, it's going to look like this, right? It's a little bit more flatter, or it goes still from the bottom, it goes to the top right, but it just approaches this horizontal asymptote. That's kind of the way we should look at it. So same as before, some examples. So tangent of 0 is going to be 0. Tangent of pi over 4, it's 1. Tangent of negative pi over 4 is going to be negative 1. What happens at pi over 2? Well, remember that tangent is a function of sine over cosine. That's its definition. And cosine is 0 at pi over 2, then this must be undefined. Right? That's the answer. And then tangent at pi over 3 is going to come out to be square root of 3. So inverse tangent of 0 is going to be 0. And I didn't make the little picture here, but I did on the previous slides. So think of this as the unit circle, and these are the only places where your answers can come from when you're talking about the inverse of things. Okay? Then we're going to keep going. Well, what is the tangent inverse of 1? Is going to be pi over 4. Right? There's only one place between negative pi over 2 and pi over 2 that gives us 1, and that is pi over 4. What is the tangent inverse of negative 1? Well, same thing except negative. Now we get to pi over 2, and we're kind of figuring out, is there a way to get the inverse of this? And the answer is no, right? You can't really plug in an undefined value. Or you could plug in something that's outside, like, I don't know, maybe over here. There's a value like 2 pi over 3, right? And so what's going to happen is that if you do this on the calculator, it's going to give you a domain error. It is just saying the input that you are plugging in is outside of what the function can compute, right? That's what's going to happen whenever you plug in a number that's bigger than pi over 2, or a number that's just not in the domain. And the last is going to be the square root of 3 is going to be equal to pi over 3. Right, the inverse function evaluated at square root of 3 gives you pi over 3. Here are some examples of what we're talking about. So if you evaluate sine inverse at the number 0.47, then depending on what your calculator is on, you will get some answer, right? For me, I got 0.489 radians because my calculator is on radians right now. If I was to switch over to degrees, then my answer is going to be some number in degrees. Alright? Oftentimes it's not the same. Very, very unlikely that the answer is the same, whether we are in degrees or in radians. So, just for example, this is the same thing as 28.03 degrees, right? So very different. So you want to know what mode you're in so that your calculator gives you the right answer. Or at least you want to know, right? You want to understand your answer. Cosine inverse of 4 over 9 is 1.11 radians. Okay? Tangent of negative 30, or tangent inverse of negative 30 is negative 1.3, well, 1.54 if I round up, radians, right? And you get the idea. Whatever your calculator is on, that's the units of the answer that you're going to get. Let's do a small overview of the different functions that we've talked about and another thing that we can expect for the future. So as the input of perhaps sine and inverse sine, we only talked about numbers, but we can have functions. So like you see here, I could say sine inverse of x. In both cases, you do get back the x value that you inputted. However, the value of x is going to depend on whether you have the inverse outside or inside as the innermost function. And what do I mean by the innermost function? I mean this, instead of the parentheses. Because you're doing that first. Whatever number you get, then you do the other function outside of it. That's the outermost evaluation of the number. Okay, so whenever you have a number inside, you're computing some angle and turning it into a ratio of lengths. And then when you do the inverse, you're going back from a ratio of length and getting back an angle. Okay, so let's see that in action. So for example, I have, what is the sine inverse of sine? Well, that one's a tricky one because it really doesn't fall within the pi over 2 to pi over negative pi over 2 value for the inverse of sine. So that one's actually going to be an error or a domain error. Example B, we're going to look at the inverse of sine of pi over 3. So if you just kind of go through the process, you figure out, okay, sine of pi over 3 is right here. and sine of pi over 3 is square root of 3 over 2. Then you have sine inverse of square root of 3 over 2. Well, it just comes back up to pi over 3, right? So in this case, since the input was actually inside of that negative pi over 2 to pi over 2, then it works out. Okay? Same here. You're going to evaluate cosine at 2 pi over 3, and then whatever you get, you're going to come back and find the inverse of it. So, since for cosine, we are looking at this region here, and 2 pi over 3 is in that region, then we are good to go. Okay? And then there is the last example where we have sine of 5 pi over 6, and if you notice, 5 pi over 6 does not happen within the region here of the right hemisphere of the unit circle. 5 pi over 6 actually happens over here. Let's see. Somewhere here. And what is the value of sine? So remember that all students take calculus. So here sine is positive in the second quadrant. So we're going to be left with sine of negative 1/2. So not negative, sine inverse of 1/2. And then you apply the inverse of it. And where is sine 1/2 within negative pi over 2 to pi over 2? Well, it happens here at pi over 6. So notice how those are not the same, but pi over 6 is the answer to this question. So these are examples when you have the same function and its inverse, right? Like the inverses of each other. But what if you have something totally different? Like for example here. So you cannot just say, well, the answer is 7 over 24 and that's it. So what we need to do is understand, right, that whenever you have the inverse here, that is going to give you an angle, right? So tangent inverse of 7 over 24 gives me some angle, some theta. So remembering the SOHCAHTOA definition, we're going to make a triangle. Since tangent is positive, then we're going to put it in the first quadrant. If it were negative, we'll do it in the second quadrant. Right? Okay. What is the definition of tangent? Well, opposite over adjacent. And look at what we have here in the argument is some kind of ratio. And so that definition is opposite over adjacent. This should look familiar and hopefully not too scary. So we need to find the value of the hypotenuse. Well, in this case, is going to be 25. 24 squared plus 7 squared equals to c squared. Do the math and we get 25. But then, once we figure that out, you can say, well, this is really just sine of whatever that theta is. And then what is the definition of theta? The definition of sine is going to be opposite over hypotenuse. So this is going to be 7 over 25. So sine of tangent inverse of 7 over 24 is going to be equal to 7 over 25. And that will be the answer for it. using that idea that tangent inverse gives you back an angle theta. Well, we can solve for it this way and then evaluate the outermost function. That's going to be it for 4.7 and inverse of trig functions.